Hello everyone and welcome to a new episode of All Things IDA. Today we're going to discuss how to do binary search, finding binary patterns, finding single bytes, but mainly doing binary search, the equivalent of the Alt-B hotkey or the one that we find in the search menu, Alt and sequence of bytes, so basically sequence of bytes. Alright, let's get started. Okay, so let's first learn how to search for a single byte. And searching for bytes are found in the bytes.hpp header file. So the first method we're looking for is find byte. Find byte takes starting address, size, and the actual byte unsigned character that we want to search and some binary flags. This should be one-to-one in IDAPython. So if we just quickly inspect the find byte, we'll see it has start, size, value, and returns, and the flags, of course. So let's see how that works. So let's say we're gonna start from the beginning of the database. So EA equal IDAPI dot get INF. INF get min EA. That's for our start, and our end range is the max EA. And now let's see we're not gonna do a loop for now. For now, just simple find. So let's see, IDAPI find byte. All right, so starting from EA, size, and so the size here we're gonna simply say and EA minus EA. And what are we looking for? Let's look for example, the FF byte. Let's look for FF. And flags here, it says it should be bin search. So bin search are just down here. We're gonna look for bin search case sensitive. We have other flags we can use accordingly. So let's just do bin search. Now, if this function fails, we should get a bad EA, bad address. So if EA equal IDAPI dot bad address, nothing found. Else we found something. Okay, so let's test it. And our first match is at this address 010. And so remember, we cannot really have the focus in the middle of the instruction, but anyway, what we searched for is exactly at this address. Now, if I was looking for some other byte, let's say EC, I will still get the address 401002, but when I double click on it, it will take me to the head. So let's type, for example, looking for EC, search. So indeed, it found it at the second byte from this address, but if I double click, IDA will always focus on the actual item head. Alright, so now let us turn this into a loop and find all occurrences. And like this, we're going to learn the coding pattern for that. So let's find for all occurrences. Again, let's just search for the FF, for example. And let's wrap this in a loop while true. And now if we don't find, we can simply just break. And here we'll assume we found something. And since we're looking for a single byte, you just have to remember that we advance in our search. Now this remains valid since we are updating each time we find a byte, we return the new start address, so to say, which we're gonna pass again to search. So the end minus the actual current address will diminish the size eventually of our search space. So this should be good enough for us to advance and search correctly using this API. All right, let's run it. And we have all those locations that have FF. We did not filter where they are. Now, if you want to search for them in the code only, and if they are, for example, not in the middle of the instruction, we can do that. So here we found an FF somewhere in the middle, 5A. So just we found it multiple places, basically 5.8, 5.9, and so on. If we want that kind of distinguishing, for example, remember we can use the flags. We can get the flags, and if IDAPython dot, for example, is, remember we have is heads we can use, and we have the is code as well we can use. So we can check if is head and is code, then that's a valid match for us. This will find if it's the beginning of a defined item and also is made as code. So now let's just sample a few matches. For example, here is exactly at 10. Let's pick this one. Here as well, 0A starts with FF, and so on. Now you might be tempted to say, okay, let's look for FF15 and so on. We can add like a next byte check as well on top of the find byte, but we're not gonna do that. We're gonna now explore how to do wildcards and more than single byte match. Now let's look at other API methods. What we want is the binary search method. So we have a bin search as it stands. It's basically one of the obsolete methods, and we are advised to use bin search 2. Now if we try to see what the API of bin search 2 is to see, and it seems that it's not directly accessible through IDAPython. We can basically go for bin search 3, which is available. Let's see, bin search 3 seems to be available. Now let's just go to the root of those issues and see why they're available, why they're not available. I'm gonna go to the source code of IDAPython to swig bytes and search for bin search. So basically this is where we can see the directives that we pass to swig when we are wrapping the native APIs into IDAPython. You can see that we explicitly ignore bin search and then rename some internal method we have in the pywraps to bin search. It's fine. But also we rename as well the bin search 2, that's why it's no longer available to us, into bin search. So effectively bin search is an overloaded method. So one is from an internal pywraps implementation and one that directly maps to the bin search 2 from the SDK. So if we want bin search 2 really, we can access it through the bin search. And here we can see how bin search, one version of bin search is also ignored. So let's see how many bin searches are there in the SDK anyway. So here we can see we have 2 bin searches in the SDK. The one with the mask and the image are excluded. What is left is this one, which also have been renamed to bin search. Since this is coming from bytes, we can quickly let me show you. It's gonna be inside the built-in modules. So I'm gonna use directly the low-level modules, not the Python versions. So these are native Python modules, and then simply inspect idabytes.bin search, and we should see 2 forms of documentations. One that basically have the bin search, a py bin search, and one that is not the ignored one, but this one. So here, so we have bin search. This is one implementation, and this is here. Takes basically the compiled binary pattern vector, and then we have another one, the py one, that has a different prototype. Now, if you're really curious, I'm gonna quickly show you the internal of this one, py, and we should see basically, so the py bin search is the new another form of it that is also exposed as bin search in Python. All right, so now that we know the internals and so on, I'm not gonna be using the py wraps version, I'm gonna be using the SDK version. All right, so basically I wanna use a bin search 2, which is exposed as also bin search, that takes the same set of arguments as we can see here. Okay, so let's make a new bin search 2 example, and let's formulate it. So we need start EA and EA. This time we're not passing a size, we're passing start and end. So we can also say end and start, or we can repurpose EA because we're gonna update it to advance the search. So we're gonna start from the lower address to the top address. Now what about a compiled binary pattern vector? So this is an output argument, and we can see as well here in IDAPython that's what it needs. Let's call this pattern and create an empty object for it. Now we're not gonna create that vector, so this is a vector of compiled binary pattern. We're not gonna formulate this manually. Instead, if we look at the documentation of bin search 2, it says parse binary, use parse bin pattern string. And so basically we're gonna be using this method here. So let's inspect this method. And so this method as well is pretty similar, just different mapping. Let's see. Yeah, out, okay. Then the address basically related to, we can pass, for example, an address, maybe this entry point of the program. This will just help IDA in the encoding. The pattern, a radix, what are we gonna encode, for example, those basically, we're gonna pass hex strings, so we're gonna pass radix 16, and also the string literal encodings. This will, if we're gonna do a text search, we will be basically choosing to encode it as Unicode, like UTF-8 or UTF-16 and so on. But first, let's look for that pattern, indirect call, followed by a test AX. Let's do that manually. So I'm gonna do Alt B here, and that's the pattern I formulated, FF15. I put 4 question marks just to make this as a wildcard, so that's what we're calling. And then 85C0. So here we could find, for example, all the calls of this form. Let's see, can we do that programmatically? So here we have 7. Let's now go back and now formulate, call the parse binary pattern. So let's go for parse binary pattern. It returns true or false. So let's say okay equals. And now let's let me call it. All right. So first thing is we need to pass the pattern. Address, let's just pass the entry point. We can pass bad address as well. And for the pattern, let me copy the pattern that I just formulated. So I'm gonna just pass the same pattern, radix 16. And here by default, I'm not gonna change those for now. The default is the bytes per unit is 1 byte per unit. So that's good enough, basically, just 1 byte per unit. Now, while this says it's going to return a bool, also here we have an error buffer, output error buffer. This will, if it fails to parse, then it will return none. So for example, if OK is none, print. Otherwise, it seems to be returning an empty string, as we will see. So if OK is none, fail to compile, else we succeeded. So for now, it's not gonna be none. So succeeded. But if I introduce something like a bad hex character or something, we get an error, and it's just suggesting, do you want to search a string? I'm gonna say no, forcing it to fail the parsing, and it returns none. So now that we basically can handle this, I think maybe we should wrap this in a function. All right. So if we could not compile the pattern, let's just return false. All right. So now we have compiled the pattern successfully. Let's go back to, remember bin search is bin search 2. So we're gonna do the bin search, IDAPython.bin search. We need start EA and EA data and flags. Okay. So IDAPy dot bin search. Start EA is basically our EA here, and EA is gonna remain and EA. Our compiled binary pattern vector is the pattern, and the flags as well is gonna be bin search, the same story. So we're gonna say bin search case sensitive. And let's try to see here what happens when we display it. Okay, now let's call test. So our first pattern here, we found it here. Great. Now the question is, can we turn this into a loop? So let's put this in a while loop. So we only need to compile the pattern once, and here we're ready to just simply wrap our search in a loop. So while true, let's search for the same pattern, binary search. Of course, now if EA is no longer found, let's bail out. Otherwise, let's basically display the address. Now the question is, how much to advance? We need to know how much to advance so we can search next. So let's just take a quick break here and discuss a bit about what happens in the pattern and how we can get the actual full length of the compiled or parsed binary pattern. So here, and let's also take a look at the SDK real quick. So if we go back to the bin search 2, which takes a compiled bin path vector, which is a vector of compiled binary pattern. So depending when we parse the string, we will get a vector or an array of compiled binary patterns. Each one has bytes, mask, and so on and so on. So we're gonna basically get the total bytes that are compiled from that pattern. So here, for example, we can see we have 6 and 2 to give it 8. Let's look at how many, because this is a vector. So let's print len of pattern. Here it just happened to have a single compiled binary pattern in that vector. And let's display then how big is pattern of 0 dot the bytes. We can display the bytes. So these are the bytes, and let's also display the mask. let me clear the screen. And so the bytes, we can see all those are my bytes. And the wildcards got replaced with the zeros to formulate the mask. That's how IDA internally builds this thing. But now we can see already how many bytes, if we found a pattern, we need to advance. So if we say then simply, let's get the len. So we need to advance by 8 bytes. But we don't want to hard code just one. We can simply say, for example, pattern len equal the summation of a pattern of the len of a pattern dot bytes for pattern and pattern. Let's see now what this will give us. Let's clear the screen. So we did get the same value 8. So this is much more solid way to get the bytes. So I'm gonna use that. And here for advancing, just clear the screen. And for advancing, we're gonna advance by pattern len. So pattern len. And let's just get the pattern len directly after the compilation. Okay, so we have the pattern len. We're advancing. Let's test this out. Run. Maybe we can also display iMatch. All right, so here we have our 7, and here we have our 7 as well. And like this, we are basically binary search 2 of those. We could have equally looked for used bin search 3. Just it takes an additional argument which gives us the index in the pattern, basically, just the index in our vector. But bin search 2 is enough by itself. Finally, let's now take a look at how we can search for combinations of binary and literal strings. So let's enumerate literal strings. Let's find some literal strings. For example, this mixer open here. I'm gonna first search for mixer open followed by 0, or let's just search for mixer pattern everything. All right, let's search for mixer pattern. In this case, what do I need to change for now? How to search for a string. So for the string, I need to, based on the documentation, the examples at least, if I'm going to search for a string, I have to wrap it in quotes. So I'm gonna switch the string to single quotes in Python and wrap the actual string, pass it in double quotes for IDA. Okay, for now the radix will not affect the literal strings. And what about the string encoding? So for now we're gonna leave it as well the default value, but in a second we're gonna show you how to search for Unicode strings. So we're gonna simply change the string encoding. So let's say mixer open. We're gonna, for now, maybe we'll find a lot of mixer opens. Let's see, mixer open. There's only one. It's okay. I'm gonna make something like that. Once we add a mix of strings and bytes, we will see how it works together. But for now, let's see. Run it. And indeed, that's the only address here. So now let's suppose I'm looking for mixer open, but not followed by 0. Here you can see the 0 terminator. So if I put 1 here, for example, it should not find anything, like it did not even find anything at all. Now we will say, okay, let's find the 0 terminator, then followed by 61, 0, 0. All right, so let's add. So here we're looking for 61, 0, 0, and supposedly as well like question mark 69, question mark 69. Search. And we could find now a mix of a string, and we can also maybe precede it with, let's say, mixer open, which is directly preceded by 0. We can also search for the 0, and we still found it. So now let me show you how to look for Unicode strings. So now I'm gonna switch database and open one that has some Unicode. So before we solve this one, we need to talk about string encoding. So here, if you remember, for when we did the parse bin, we have string literal encoding, and we had some special values here, like default values. So I get the default 1 byte per unit. Now we need to specify a different encoding per however the encoding we desire to search for, so that IDA encodes the strings correctly and then really do a binary search. So there are helper methods in alt about the encoding, and in particular what we're gonna be using. So for example, we have a bunch of like get encoding quantity and get encoding name and so on to enumerate the encodings. And also once we have like the indices from the quantity and enumerating from 0 to the quantity, we can get, given the index, we can get the encoding bytes per unit, but we don't know the indices. We're not gonna enumerate. Instead, we're gonna simply either use get string type to encoding. By doing this, we can use the str literal types we've seen before, or we can also specify the name of the encoding to get the bytes per unit. So let's just test quickly. If I say here BPU IDAPy.get bytes per unit, and let's say UTF-8. And let's just display UTF-16, for example. And here we can say the encoding, and the BPUs is this one. So we should have, let's clear the screen. We should see like 1 and 2 in this case. So we have 1 and 2. So if we go back to our example, I can basically, if I want, use just like the BPUs here for the encoding, and let's say UTF-16 if you want, or as we said, could have used string type to BPU conversion. So okay, so we got that UTF-16, the proper encoding. Now let's just look for assert failed or assertion, for example. And again, double quotes for a string literal. Same story, we could have mixed something else apart from the string. And all right, so that's the encoding. Let's test it out just here. All right, that's the encoding. Let's run it. Okay, so we found assertion here and assertion here as well, it seems. So let's see the addresses. We found it at the D8, and we found AC 8C, which is in the middle here somewhere. Okay, so we covered how to do a single byte search today with the find byte method. We also covered bin search 2, which is renamed to bin search in IDAPython. We learned how to compile a binary pattern with wildcards and how to mix and match between string literal and binary search at the same time. And we covered the bytes per unit and how we can change the encoding of the string when we're doing programmatic binary search. I hope you found this video useful. If you liked it, please subscribe and put a like, and thank you very much.